Okay, today we're going to learn on chapter 1, which is on complex number. So these are some subtopics of complex number that we will learn. Okay, the basic things of complex number that you need to know. So first, a complex number is used to solve algebraic equations that don't have the real solutions. Okay, for example, we have here x squared minus 4 is equals to 0. So we will obtain x is equals to plus minus 2. However, for x squared plus 4 is equal to 0, so we will obtain x is equals to plus minus square root negative 4. Square root negative 4 has no real solutions, meaning it's undefined, so when we use your calculator, you will get syntax error. So that's why we need this complex number. So we will let j equals to square root negative 1. So our problem square root negative will be solved. Since we let j equals to square root negative 1 and j squared is equals to negative 1. Okay, let us try to do this exercise. An example. So the first example 1.1 I want you to simplify into the form of j. So again, we write j is equals to square root negative 1 and j squared is equals to negative 1. So first of all, you need to know the power, whether it's even and odd. So because we will treat differently for even and odd power. First of all, we look at the first example A. So if it is even power, so we just divide the power by 2. So 8 divided by 2 is 4. So now we substitute j squared equals to negative 1. So negative 1 power 4, which is even, so you got 4. So the answer to this is actually equals to 4. If it is odd, so you need to write negative 4j. You need to separate like this, 12 plus 1. So now it's become the 1. So it's actually 14j power 12 times j. Because we want the 12, we want it even, then only we can divide by 2. So negative 4j power 2 times 6j. So we substitute negative j squared is equals to negative 1 times 6j. So the answer is negative 4j. That's it. It's very easy, very simple. Just that you need to know whether it is odd or even power. So if it is even, you have to do as in example A. If it is odd, as example B. So let us try to do this exercise. Number 1, j power 7. So this is odd and this is even. So again, it will be j power 6j. Okay, you need to separate the 1j to make the power becomes even. And then we divide by 2. So it's become power 3 there. So j squared is equals to negative 1 power 3j. So negative 1 power 3 is negative 1. So the answer is negative j. For number 2, j power 10. So it's even now. So you just need to divide by 2. So 2 times 5 is 10. So now we substitute j equals to negative 1 times 5. So it will be equals to negative 1 because it's odd power. So that's it. Okay, now we will give the definition of complex number. So if z is a complex number, then the standard equation of complex number denoted by z equals to a plus bj, or z equals to ab. So where a and b here is element of real number. So a here is called the real part of Z, or we write as REZ. And B here is the imaginary part of Z, or we write as IMZ. So if we want to represent the complex number in a complex plane or Argand diagram, so the complex plane Z A equals to A plus BJ is plotted as point with coordinate Z, A, B. So here, real Z is the x-axis. So it's the real part, real Z. And if I am Z, or the imaginary Z is the y-axis. So A is the coordinate at x and B is the coordinate at Z. So the point of Z. So that's it how we represent complex number in the complex plane, and also the standard form of complex number. Z is equals to A plus BJ. So we commonly use this. Okay, let us try to do this example on how to express this example in standard form. So we know that standard form Z is equals to A plus BJ. And we also know that J is equals to square root -1. So for A, Z is equals to 1 plus square root -4. So we need to write -1 from the -4 here. So -4 we divide by -1, so it's actually -1 times 4. And then because this is multiplication, we can separate the square root. So we got -1 square root 4. So we know that square root 4 is equals to 2 and square root -1 is equals to J. So Z is equals to this. Okay. Next, B. The same thing, your objective is to make the -1 appear so that you can substitute with J. So here, like -8 divided by -1 is 8. So you can write 4 minus square root -1 square root 8. So the answer is 4 minus square root 8 J. You can just leave it like that, or you can try it like this, because we know that 8 can be divided by 4, so 2 times 4 J. So 4 minus 2 square root 2 J. So that will be your final answer. So can you give the answer in point? Yeah, it's also correct. If you calculate 2 square root 2 and give the answer in point, it's also correct. And give your answer in 4 decimal places. So next is the exercise. Okay, let us try to do this exercise, or you do it. Make sure you get the correct answer. So now you need to know what is mean by 2 equals complex numbers. So 2 complex numbers is said to be equal if and only if the real part and the imaginary part is equal to each other. For example here, the real part of Z1 is A and the real part of Z2 is C. So A must be equals to C. Whereas the imaginary part of Z1 is equals to B and the imaginary part of Z2 is equals to D. So B must be equals to D. If only AC is equals to each other but B is not equals to D, so the complex number is not equal. Okay, so it has to be the same real and same imaginary, then only we can say that 2 complex numbers are equals. So it's given example here, find x and y if Z1 equals to Z2. Let us try to do for A. So Z1 meaning the real is equals to the real part of Z2. So 2 must be equals to 4x. Whereas for the imaginary part, -3y is equals to 9. So we got here x must be equals to 1 over 2. Use your knowledge on how to solve equations. And y is equals to negative 3. Am I right? Yeah, okay. So that's it. You have find the found a y and x and y. So how about b? The same thing, you equate real part of z1 with real part of z2. Here is trivial here. X equals to 10. Then for the imaginary part, 5 is equals to negative 2y. So y must be equals to negative 5 over 2. So can you do for 3x plus 7y, j equals to 9 plus 28j, x and y. Just find x and y, just equate 3x with 9 and 7y with 28. You will get x equals to y equals to what? Okay. If you have any problem, just let me know. Okay, next we will proceed with the operations of complex number. So you have to know how to add, subtract, and multiply two complex number. So if you want to add two complex number, for example, Z1 and Z2, so we will add real with real part and imaginary with imaginary part. The same thing if we want to subtract, we will subtract real part with real, imaginary with the imaginary part. If we want to multiply, we need to expand on. So let us take a look at the example so that you will have a clear view on this. For the first one, so z1 plus z2, so it means 3 minus 2j plus 4 minus 2j. So remember I said real with real. So real with real here, the answer is 3 plus 4 plus negative 2 plus negative 2j. So the answer will be 7 minus 4j. That's it for the first one, for A. And if you want to subtract two complex number, so it's basically the same thing. Okay, just we change the sign here, subtraction. So again, 3 minus 4. Okay, so the imaginary part is negative 2 plus 2 because it's minus, negative, negative, so it becomes positive. So 3 minus 4 is negative 1 and this one is 0. So the answer is just negative 1. Okay, how about if we perform the multiplication? Multiplication meaning you multiply z1 and z2 here. Okay, so you need to expand everything. Okay, so you will get 12 minus 6j minus 8j plus 4j squared. And then you simplify. We know that j squared is equals to negative 1. So you just simplify it. 12 minus 14j minus 4. Am I right? Okay, next, continue, will be 8 minus 14j. That's it. That's the answer for the example C. So that's it. So now let's try to do exercise 1.4. Okay, it's given here z1 is equals to 3 minus 5j and z2 is equal to 1 plus 2j. Find the multiplication z1 with z2 and also solve for number 2. So the next important things on complex number is the conjugate of complex number. So the conjugate of z complex number can be defined as z bar is equals to a plus bj bar, and it actually means a minus bj. So meaning we change the sign of the imaginary part only. So obtain geometrically by reflecting point z on the real x-axis. For example, if we have RE z and imaginary z. So for example, z is here. So this is A, this is B. So the conjugate of z is A minus B. So it's basically here. So that's why it said reflecting point z on the real x-axis here. Reflect here. Here it's reflect here. Z with the z bar here. That is what is meant by the conjugate. You just change the sign. If it is negative, you change to positive. If it's positive, change to negative on the imaginary part only. Let's try to do this example. Remember, the conjugate of z is equals to A minus bj. If z equals to A plus bj, then z bar is equal to A minus bj. So here z is equals to 1 plus j. So z bar must be equals to 1 minus j. So we just change the signs on the imaginary part. So here z bar is equals to 2 plus 3j. And here, is it positive 16 or negative 16? What do you think? So it's still negative 16 because there's no imaginary part here. So for the real part, it maintains the same. And for D, it will be negative 8j. That's it. Very simple. The conjugate of complex number is just that we change the sign on the imaginary part. So can you do exercise 1.5? So make sure. Okay, now since you have learned the conjugate of complex number, so now we can solve the division of complex numbers. So in order to perform division of complex numbers, you need to multiply by the conjugate of its denominator here. So you multiply the conjugate on the numerator and also on denominator. So let us try this example. So we need to multiply by the conjugate of denominator here, 1 minus j. The conjugate is 1 plus j. Okay, so you need to apply your knowledge on multiplication. So 3 times 1 is 3 plus 3j plus j squared. Okay, and then divide by 1 squared minus j squared. Okay, right. So we simplify this. 3 minus 1 is equal plus 4j divided by 1 plus 1, so which is equals to 2 plus 4j divided by 2. So we can simplify more. 1 plus 2j. So the answer is this. Okay. So basically for division of complex number, the keyword is conjugate. So you need to multiply by the conjugate of the denominator to up and above, or numerator and denominator. Okay, so let's try to do some more examples. Okay, for B, so B, the conjugate of this one is we times by negative 3j. So it will be negative 6j plus 12j squared divided by 9j squared, or negative, sorry. So we can simplify it here. It will be negative 12 minus 6j divided by negative 9 or positive 9, because j squared is equals to negative 1. So when you simplify this, you get negative 12 over 9. When you separate real and imaginary, 9j. So the answer will be negative 4 over 3 minus 2 over 3j. That's it. Okay. So we get the correct answer here. This one also correct. So for C. So for C, you need to simplify in terms of j first. Here we have j power 3, j power 12, j power 7. So again, 4 minus j squared j, okay, because it's odd, and j squared power 6 because it's even, plus 5j power 6j. Okay, so it's become 4 positive j, okay, because j squared is equal to negative 1, and then here is negative 1 power 6, which is okay, 1, and then we just write 1 by 1, okay, just to avoid confusion, plus 5j squared power 3j, okay, because the negative give different answers, so to avoid mistake, it's okay for you to write 1 by 1. So 1 plus or minus, because it's negative 1 times 3, so 5, 1 minus 5. Am I right? Okay, now you have to multiply, then only you can multiply by its conjugate. So 1 plus 5j, 1 plus 5j. Okay, so you perform the operation, you continue here. So it will be 4 plus 20j plus j plus j squared divided by 1 squared minus 25j squared. So it will be, the answer is 4 minus 1 is 3 plus 21j divided by k1 plus 25. So it's equals to what is it? 3 plus 21j divided by 26. So the answer is it something wrong here? So it's 5j squared here, sorry. J plus 5j squared. So it's actually 4 minus 5. So it's negative 1 plus 21j. So here it's actually negative 1. Alright, so it's okay for us to make mistake. So we separate real and imaginary. Okay, so we get the correct answer. Okay, for D, here you need to separate, okay, the first term and the second term. You find the you conjugate this one and you conjugate this one separately, then you subtract first one, subtract the second one. Okay, I left that one as exercise, so you try to do this and make sure you get the same answer as the given answer. So There's also some more exercise. This is a simple one. I hope you can try to do it by yourself and check the answer. Okay, settle on operations of complex number. So now we'll continue with the complex plane and arc diagram. So the first thing that you need to know is the modulus of complex number. So R, or we write it as Z modulus, is equals to square root of A squared plus B squared. Again, Z is equals to A plus BJ. Okay. So what is actually means by modulus? So modulus is actually the shortest distance from the origin to the point Z. Okay, so R is here if you want to represent in complex plane. So basically we just squared A and squared B and we square root, we will get this length. Okay, length from the origin to the point Z. Okay, let us take a look at the example. Okay, find the modulus of Z. For example A, Z is equals to 2 minus 3J. Okay, again we write the formula for modulus of Z or R is equals to A squared plus B squared. The imaginary part and the real part we squared it. We add it together and we square root the answer. So for A, R or Z modulus is equals to 2 squared plus negative 3 squared. And the answer is 4 plus 9, which is equals to square root 13. Okay, just give the answer in terms of square root. It doesn't matter. So R, for the second one, B, negative 3 squared. Okay, A squared plus B squared is negative 4 squared. So the answer will be 9 plus 16. So 9 plus 16 is square root 25. So the answer is 5. Okay, that's it. Very simple for modulus. So you can try to do exercise 1.7. Okay, another important thing on complex number is the argument of the complex number, or we say the theta. Okay, argument of Z or theta is equals to tangent inverse B over A. So how come we get this? So we have, for example, here, okay, R is Z and imaginary Z. So for example, we have Z here. Okay, this is the origin. So this is Z. So we can actually find this angle. Right, theta. Okay, because this is A, this is B. So tangent is the opposite side of theta divided by the adjacent side of theta. So theta is equals to tangent theta is equals to B over A. Right? Because this is B, this is A. So that's why theta is equals to tangent inverse B over A. So that's why you got this formula. But this is for the first quadrant. Okay, for the first quadrant, alpha is equals to theta. But for the second quadrant, alpha is basically theta here. So we let alpha equals to tangent inverse B over A. This is actually the general formula. So this is a specific one. Okay, so alpha here, to get theta, 180 minus alpha, because the one that we obtain from tangent inverse B over A is from here, right? It's from this direction. This is to this direction. And for the third quadrant, it's 180 plus alpha. Okay, and here 360 minus alpha. Okay. Note that when you calculate alpha, you will get negative for second quadrant and also the fourth quadrant. Okay, so you ignore the negative. So the negative, actually the direction is clockwise. Okay, it's measured clockwise, so it's negative. If it is measured anti-clockwise, it will be positive. So alpha, we ignore the negative sign. So we just take the value of the degree. Okay, never mind. Let us take a look at the example. Okay, so alpha equal to theta. Okay, here. Find the argument of sine. So first of all, you need to know where is the point located, or the location of the complex number. For example, A, can you guess where is it? It's 2 positive and it's negative. So it's on the fourth quadrant. So remember, for fourth quadrant, 360 minus alpha. So we want this theta. So find the alpha first. Alpha is equals to tangent inverse negative 1 over 2. So the answer is negative 26.57 degree. Okay, remember I said ignore the negative because the negative is just the direction. So theta, because it's fourth quadrant, okay, fourth quadrant. So theta is equals to 360 minus 26.57. Okay, ignore the negative signs. So the answer will be 3.43 degrees. So that's the answer for the first one, A. How about B? Okay, B I write here. So B, you need to know where's the point located. Okay, so x is negative and y is positive. So it's basically the second quadrant. So this is our alpha. So you want the theta here. So we find alpha is equals to tangent inverse 5 over negative 3. So the answer is 59.04 degrees. So for theta, because it's in second quadrant, so we write theta is equals to 180. So it's negative here, but we ignore it. Minus 59.04 degrees. Okay, so the answer is equals to what? 120.96 degree. That's it. Okay, the second one. Okay, how about C? Basically the same thing, yeah. So C is located in the positive x, positive y, so it's in the first quadrant. Okay, first quadrant. So alpha is equals to theta, so just calculate theta is equals to tangent inverse 1 over 1. So the answer is 45 degrees. So this is very simple. How about D? So we have to sketch first, okay? So here is the x is 0 and y is equals to 2 here. Calculate. Because it's obviously 90 degree. So theta is equals to 90 degree. That's it. Okay, so please try to do exercise. Exercise 1.8. Okay. Okay, now we have come to the polar form of complex number. So what we have learned before is the standard form of complex number. So here, how do we get A equals to R cos theta and B equals to R sin theta? So if we want to find this theta, so we use the rule that we have learned in school, is theta is equals to, or cos theta is equals to the sides, the adjacent sides divided by the hypotenuse. So it's A over R. And sin theta is equals to the opposite side divided by the hypotenuse. So that's why we get A is equals to R cos theta and B is equals to R sin theta. So how about this one? Then theta is equals to tangent inverse B over A. This is because tangent theta is equals to the opposite sides divided by the adjacent side. So theta is equals to tangent inverse B over A. So that's it for polar form of complex number. So from Z equals to A plus BJ, we will substitute A equals to R cos theta and B equals to R sin theta, and we will get the polar form. Okay, here it will be Z is equals to, since Z is equals to A plus BJ and our A is equals to R cos theta and B is equals to R sin theta, so A must be R cos theta, okay, Z must be plus R sin theta J. So when we factor out R, will be cos theta plus J sin theta. So that's how we get this polar form. We can also write like this. Okay. So let us try to do this example. Okay, for A, let Z equals to 2 minus J. So what do we need now is the R. What is the value of R? And the theta in order to write it in exponential form. So we use the knowledge on how to find the R or the modulus of Z before. It is 2 squared plus negative 1 squared. So the answer is square root 5. How about the theta? So it's located in the, okay, 2 here on the x-axis, negative 1 here. So it's scattered on the third diagram. Oh no, sorry, fourth diagram. So it'll be 360 minus tangent inverse 1 over 2. So it's equals to 360 minus 26.57 degrees. So remember, we always ignore the negative sign because it's just a direction. The answer is 333.43 degree. So we have R, we have theta. So Z is equals to square root 5 multiplied by cos 333.43 plus J sin 333.43 degree. Okay, don't forget the degree. So that's it for the complex or polar form. Let us try to do for B. So B, so find the R is equals to 3 squared plus 5 squared. So write the answer. So it's located in the in the second quadrant here. So it will be 180 minus tangent inverse 5 over 3. Okay, so what's the answer? So here is square root 34, and this one is 59 point, oh, sorry, 180 minus 59.04 degree. So the answer is equals to 120.96 degree. So we have now both the r and the theta. So the polar form will be square root 34 multiplied by cos 120.96 plus j 120.96 degree. Okay, how about C? So r is equals to 2 squared square root, so it's equals to 2. So where is the point located actually? So it's x is 0 and y is 2. So it's here. So here you don't have to calculate the angle because it's trivial here. You can see it's a 90 degrees. So theta is equals to 90 degrees here. So your z is equals to 2 cos 2 cos 90 degree plus j sine 90 degree. So that's it. Okay, so you have to know where is the point located, then only you can find the correct polar form. So next, let us try to do the exercise regarding polar form. Okay, so I hope all of you are clear already on how to convert from standard form of complex number to its polar form. So now in this example is given the polar form of complex number, so you need to give the standard form. So meaning you have to write in z is equals to a plus bj. So what you need to do is just use your calculator. Okay, so here is cos 60 degree, you find the value, you multiply by 3, and then sin 90 degree, you press the value and multiply by 3. So it will just be 3 times cos 60 is 0.5 plus j cos 90 is 0.8660. So you just expand it and you will get 1.5 plus 2.5981 J. So that is the standard form that we want. The second example, z is equals to, okay, cos 90 degree is equals to 0 plus sin 90 degree is equals to 1. So z is equals to j. That's it. Very simple. How about the next one, c? For c, z is equals to square root 8. Cos 180, if you use your calculator, is negative 1 and plus 0 j. So when you expand it, z will just equals to negative square root 8. That's it. So it's very simple actually. You just use your calculator and expand it. So I hope you can do exercise 1.10. Okay, now we want to do operations in polar form. So if we have Zn equals to Rn, bracket cos theta n plus j sin n theta. So if you want to multiply Z1 and Z2, so here Z1 will be R1 cos theta 1 plus j sin theta Z1 and Z2 will be equals to R2 cos theta 2 plus J sin theta 2. So if we want to multiply Z1 and Z2, we will multiply the modulus, but the angle or the theta, we will just add it together. Whereas for division of Z1 with Z2, the modulus R, we will divide by R1 divided by R2, and the angle we will minus. So this is a theorem to this operation, multiplication and division of two polar form. Okay, we just follow this theorem. So let us try to do them for this one. So we are given Z1 and Z2 and it asks for Z1 times Z2. So remember, we just multiply the modulus. So here 3 times 2, but the argument or the theta we will add it together. So here will be cos 45 plus 90 degree. Okay, and then for the imaginary, J sine 45 plus 90 degree. So what's the answer here? So it will be 6 cos 135 degree plus J sine 135 degree. That's it. But don't stop there. You should give the answer in the standard form. Okay, give your answer in the standard form. We have learned before how to find the angle, the standard form from the polar form. So the answer to this is negative 4.2426 plus 4.2426J. Okay. So what if we divide the two complex numbers Z1 divide by Z2? So as I mentioned just now, the modulus we will divide. Okay, will be 3 divided by 2 because Z1 divided by Z2. So the angle we will minus. So or subtract 45 minus 90 degree plus J sine 45 minus 90 degree. Okay, so now we simplify it. So it will be 3 over 2 cos negative 45 plus J sine negative 45 degree. So you just press your calculator, you'll get the answer equals to 1.0607 plus or minus minus 1.0607J. So that's it. So to multiply and divide two polar form, so of complex number, we just have to follow the theorem. Okay, that's it. So for B, let us try to do these two. Z1 and Z2. So it will be 5 multiplied by 2 and cos 60 plus 200 plus J sine 60 plus 200. Okay, and then you simplify it. Okay, we will get 10 cos 260 plus J sine 260 degree. Okay, it is all degrees here. So just use a calculator to find the answer. The answer here is negative 1.7365 plus, oh sorry, minus 9.8481. J, don't forget the J. Okay, it's very simple. Just follow the theorem but give the answer in the standard form. Okay, for Z1 divided by Z2, so the modulus Z1 divided R1 divided by R2, so because, where is it here? 60 minus 200. Okay, plus sine 60 minus 200. Okay, so it's actually 5/2 cos negative 140 degree plus sine 140 degree. Negative, don't forget the negative. If you had negative, just put negative. And then use your calculator to find the value. So the answer are negative 1.9151 minus 1.6070J. So that's it. Okay. So I hope you can try to do the exercise regarding this one in next page. Okay, please do this question, exercise 1.1. Just refer the previous example. Okay, we have the standard form of complex number, the polar form of complex number. So now it's the exponential form of complex number. So for the exponential form, we write it as z equals to r exponent theta j. So theta here is measured in radians. And theta, exponent theta j is equals to cos theta plus j sine theta. Okay, so from z equals to r cos theta plus j sine theta, we substitute with exponent theta j. So that's why we get in this form as the exponential form. Okay, this is a very basic one for the exponential form. So let us try to convert this complex number from standard form to exponential form. So this exponential form, we have z equals to r exponent theta j. So you need to find r, you need to find theta in radian. So what we have learned before, to find the theta is given in degree. So in degree, okay, we need to multiply by pi divided by 180 degree. So theta radian is equals to theta in degree. We multiply by pi over 180. Okay, so let us try to do it for A. So you find the R first. Okay, as simple as that. 2 squared, 1 squared. So we get R equals to square root 5. Am I right? Okay, now we know that this complex number is located in the second quadrant. So theta in degree is equals to 180 minus tangent inverse 1/2. So theta is equals to 180 minus 26.57 degree. (153.43 degree). So now you need to convert the theta to radian. So theta in radian is equals to 153.43 times, okay, we just write like this, times pi divided by 180 degree. So just divide the degree and give the answer in terms of pi. So the answer will be 0.8524 pi. Okay, so we are not done yet, so we have to give the standard form. So z is equal, or not the standard form, the exponential form. R is square root 5 exponent your theta is 0.8524 pi. Don't forget the j. Okay, 0.8524 pi j. That's it, the standard form of the complex number. Okay, let us try to do for B. The same thing, you need to find the R. So here R is equal to square root 10. So where is the point located? So it's negative here and negative here. So it's in the third quadrant. So this is alpha. So theta is equals to 180 plus tangent inverse 3 over 1. Okay. So your theta is actually equals to 180 plus 71.57 degree. So the answer is equals to 251.57 degree. So remember, this is theta in degree, you want theta in radian. So 251.57 multiplied by pi divided by 180. So the answer would be 1.3976 pi. Okay, so your exponential form will be square root 10 exponent 1.3976 pi j. That's it. Okay, I hope all of you got this, how to convert from standard form to exponential form. So what you need to do, you just like you want to convert to polar form, but the degree you have to change in radian mode, okay, by using the formula. Okay, leave your answer in terms of pi. Okay, next, please try to do this exercise 1.12. You just need to convert from standard form to exponential form as the previous example. Okay, now the same as polar form, we also need this theorem to perform multiplication and also division of two complex number in exponential form. So it's basically almost similar. Okay, if you want to multiply two polar form in exponential form, we want to multiply complex number in exponential form. We need to multiply the modulus and we add the power. If you want to divide, we will divide the modulus and we minus the power. Okay, don't waste our time. Let us try to do this. So we want to find z1 times z2. So we will multiply the modulus or the r and then we add the, so I here is the same as j. I forgot to change this. So pi over 4 plus pi over 3 j. So is it j here. J, 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 J. Okay. So now, how to perform this? So 6. Okay, if you do not know, you factor out the pi first. Okay, pi j. So it will just be 1 over 4 plus 1 over 3, which is equals to what? 6 exponent 3 plus 4 is 7. 7 over 12 pi j. That's it. Okay, if we want to divide z1 divided by z2, it will just be 3 over 2 exponent pi over 4 minus pi over 3j. So the same thing, if you're confused, you factor out the pi first. So it will be 1 over 4 minus 1 over 3 pi j. So the answer will be exponent negative pi over 12j. Okay, that's it. Just leave the answers. Okay. Okay, next, as usual, we have to try to do this exercise to test whether you really understand this or not. Okay? Okay, this is the last subtopic in chapter 1 in complex number. So we have this de Moivre's theorem. So this theorem said if z is equals to r cos theta plus j sin theta is a complex number in polar form to any power of n, then z power n is equals to rn cos theta plus j sin theta n. So, and from this de Moivre's theorem, you don't have to find the power of this cos theta plus j sin theta. You just use this theorem. You just need to multiply the angle or the argument theta. It will be n theta here. So you don't have to do power. So the Moivre's theorem said z power n is equals to r power n bracket cos n theta plus j sin n theta. For example, if you want to find z power 3, so it will be r power 3, you power 3 the modulus, and then the angle will just multiply by 3. So that's it, very simple. Okay, let's take a look at the example. Okay, this one example. We want to find z power 2. Okay, let's let this is equal to 1. This is number 2. So number 1, we want to find z power 2. Remember, de Moivre's theorem said z power n is equals to r power n cos n theta plus j sin n theta. So it will be 3 power 2 cos 2 times 75 j sin 2 times 75. So it's actually 9 times cos 150 plus j sin 150 degree. So please give your answer in the standard form. Okay, just use your calculator. So the answer is negative 7.7942 plus 4.5 g. Okay, that's it. For number 2, the same thing, we want to find z power 3. So we power 3 the r, and the theta we multiply by 3. So 4 power 3 is 64. Cos 120 degree plus j sine 120 degree. Okay, just use your calculator to find it. So the answer to this is negative 32 plus 55.4256 G. Okay, that's it. How do we apply the de Moivre's theorem? Okay, next so please try to do this exercise 1.14 on de Moivre's theorem. Okay, if you have any problem, just contact me. Okay, so that's it. That's the end of chapter 1, complex number.